Assalamualaikum. We are from MTCS 1102A and today we will be presenting for the course code MIT 183 Calculus 1, Topic 2 which is Differentiation and Topic 3 which is Application of Differentiation. But before that, let's introduce our group members. It is consists of 4 members which is Irish, Erdina, Zihan and Khairunisa.
So the introduction of this video is that the main purpose is to explain the concept of differentiation and demonstrate how derivative can be applied to solve any complicated problems. The derivative or differentiation is simply a measure of how quickly a quantity is changing at a specific point. There are 3 techniques of differentiation that can be applied: product rule, quotient rule, and chain rule.
Differentiation or derivative is simply a measure of the instantaneous rate of change. It is a concept of a real variable that measures the sensitivity to change the value of a function with respect to change in its argument. It is used to measure the rate of change of a function y equal to fx with respect to its variable x. The significance of differentiation is to see how fast or slow something is changing, whether it is speed, temperature, money, or growth. By understanding this, we can solve real-life problems by analyzing how one thing affects another. This is why differentiation are vastly used across fields like science, engineering, and physics. For example, in science, we can measure how fast temperature change or how fast chemicals can react. Next, in engineering, differentiation can be used to design a safe building and machines by analyzing how materials react to force. Lastly, in physics, we can use differentiation to study for motion, speed, acceleration, and force. Differentiation or derivative.
Okay, for question 2, this is the problem statement. And then for A, the problem solution is first to transform root function to power function. Second, identify outer function and inner function. Third, differentiate outer function and inner function. Fourth, apply chain rule. Fifth, simplify the final answer. And for B, the steps to solve it. For the first one is identify U and V. Second, differentiate U and V. Third, apply product rule. Fourth, simplify the final answer. Okay, for question 2F, first I transform cube root of 7x squared plus ln 5x to in bracket of 7x squared plus ln 5x to the power of 1 over 3. And then I identify the inner function and outer function. After that, I differentiate the outer function first, where I get 1 over 3 in bracket of 7x squared plus ln 5x to the power of negative 2 over 3. And then I multiply it. With the differentiation of the inner function, where I get 14x plus 5 over 5x. And then I simplify the 5 over 5x to 1 over x, and after that I transform it to the simplest form, where I get 14x plus 1 over x over 3 in bracket of 7x squared plus ln 5x to the power of 2 over 3. Question 2F, first I transform. Okay, for question 2B, first I identify the u and v. So for u is equal to exponent to the power of 9x, meanwhile v is equal to secant 6x. So I will differentiate u. So u prime will be equal to 9 exponent to the power of 9x. V prime is equal to 6 secant 6x tangent 6x. After that, I will apply product rule, where u multiply with v prime plus v multiply with u prime. So it become exponent to the power of 9x multiply with 6 secant 6x tangent 6x plus 9 exponent to the power of 9x multiply with secant 6x. After that, I get 6 exponent to the power of 9x secant 6x tangent 6x plus 9 exponent to the power of 9x secant 6x. Lastly, I factor out 3 exponent to the power of 9x secant 6x in bracket of 2 tangent 6x plus 3. To sum up, I suggest applying the chain rule on question 2A when asked to find the derivative of a function that is a composition of 2 functions. Second, in conclusion, I recommend using the product rule for question 2B, as it is applied when differentiating 2 functions that are multiplied together.
So next, here are the problem statement. Okay, in order to solve it, here are the steps. First, differentiating all the terms. Then we wrote the now differentiated terms into one expression. Group the terms with dy over dx to one side. Factor out dy over dx from the terms. And then lastly, solve for dy over dx. For the first term, I use quotient rule in order to differentiate it. I set my u to be exponent to the power of 2y minus 2. And then I set my v equals to x. My u prime is equal to 2 exponent to the power of 2y minus 2 dy over dx. This is because when we differentiated y, we need to write down as dy over dx at the back. And then my v prime is equal to 1. Then applying inside the quotient rule, which is v times u prime minus u times v prime over v square. Then the differentiative from this is 2x exponent to the power of 2y minus 2 dy over dx minus exponent to the power of 2y minus 2 over x squared. So for ln 8x, I differentiate it to be 8 over 8x, 7x to be 7, y cubed to be 3y squared dy over dx, and then lastly for negative cosecant for x to be negative 4 in bracket negative cosecant for x cotangent for x. Okay, then I rewrote the terms back into one single expression, following the original expression position when deciding what terms to write down first. As we can see here, we can simplify the first term by cancelling out the x, and we can also simplify the 8 over 8x to be 1 over x. And then I group the terms with dy over dx to the left. Then factor out the dy over dx from the two terms. Finally, solve for dy over dx by making the non-factored terms into the denominator for the terms without dy over dx. So in conclusion, I suggest to use the suitable rule in order to differentiate the terms correctly, like applying techniques of differentiation like product or chain rule. This way, there will be no mistake when trying to differentiate the terms in order to get the final expression correctly. In conclusion, the rules that this question uses, which is quotient rule, helps to differentiate function written as one function divided by another.
So we're moving on to the last question, which is question 4. The question asks us to use linear approximation to estimate the value of 1 over square root of 16.88 plus the fourth root of 16.88 correct to 4 decimal places. So there's a 6th step to solve this question. The first step is to determine the value of x, and then we define the function based on x. The third step, we find the value of x naught, and then we find the value of function of fx naught function. Then we find the first derivative of fx naught function, and then lastly we apply the formula.
So the problem solution here is we need to find all the requirements needed by the formula, which is the first thing first, we need to find the value of x. So the value of x is usually given on the question and is usually in decimal form. So as we can see, there's only one value that in decimal form here, which is 16.88. So our value of x will be 16.88. Moving on to the next step is to define the function by substitute x into the value. So it will be 1 over square root of x plus the fourth root of x. And then next step, which is finding the value of x naught. So there's two terms here that we can choose to evaluate. So I chose the fourth root of 16.88 to evaluate, and the answer will be 2.0270. And then I will round off the value into an integer value, which is 2. So then I will calculate the possible value that can be equal to 2, which is 16, because the fourth root of 16 is equal to 2. So the x naught is 16. So the next step, which is we need to substitute the value of x naught into the fx function, which is it will be 1 over square root of x, 1 over square root of 16 plus the fourth root of 16, and it will be 1 over 4 plus 2, and the answer will be 9 over 4. Moving on to the next step, which is we need to find the first derivative of x naught function. So in order to find the first derivative of x naught function, we have to find the first derivative of fx function. So first thing first, we need to transform it first into x to the power of negative 1 over 2 plus x to the power of 1 over 4. And then we can differentiate by bringing the power to the front and then reduce 1 from the power. So it will be negative 1 over 2x to the power of negative 3 over 2 plus 1 over 4x to the power of 5 over 4. And then I will transform it back, and it will be negative 1 over 2x to the power of 3 over 2 plus 1 over 4x to the power of 5 over 4. And then we can find the first derivative of x naught function by substitute 16 into the first derivative of fx function, which is it will be negative 1 over 2 multiplied by 16 and to the power of 3 over 2 plus 1 over 4 multiplied with 16 and to the power of 5 over 4. And then it will be negative 1 over 128 plus 8, and the final answer will be 1023 over 128. And for the last step, we will be applying the formula, which is fx estimate to fx naught plus f prime x naught multiply with x subtract with x naught. So we will be substitute the value that we just got into the formula, which is 9 over 4 plus 1023 over 128 multiply with 16.88 subtract with 16. So the final answer will be estimate to 9.2831, since the question asks for 4 decimal places. So the conclusion is, to summarize up, I recommend to use the linear approximation formula to quickly estimate any complicated expression. So the formula will be fx estimate to fx naught plus the first derivative of x naught multiply with x subtract x naught.